Okay, in this mini lecture, I actually want to give you, as best I can put together, kind of a visual overview of this whole notion of inferential statistics on which we work in MS-264. Let me remind you that the whole idea underlying inferential statistics is that we observe data in samples, and then based on that sample data that we observe, we draw inferences about populations from which our samples were drawn. Now, what I'm going to do here is I want to organize your understanding of inferential statistics around three different types of inferential statistics. I talked briefly about this in one of our earlier mini lectures, but now I want to show it to you kind of in a hierarchical form. So the three general types of inferential statistics that we do in MS-264 are tests of differences. I'll come back to this momentarily. So of the three different types, one set of inferential statistics is tests of differences. Another type of inferential statistics test that we do is called tests of association. And then the third type of inferential statistics that we do in MS-264 is called predictive modeling. Okay? So emphasis in the last probably 2/3 of the semester of MS-264 is on inferential statistics. The last couple or 3 weeks in chapters 10 and 11, our emphasis has been on test of differences. I'll not really spend any time on this because you should now recognize that you now know how to work with 4 inferential tests of differences. A 1-sample difference of means test, a 2-sample difference of means test with independent groups, I should mention, paired comparisons, and then ANOVA. And when our nominal variable has only 2 levels, we're either going to do a 1-sample difference of means, 2-sample differences means, or paired comparisons. When our nominal variable has 3 or more levels, we have to do ANOVA. Okay? So this is chapter 10, chapter 11. You should have it pretty well underhand. What we do in chapter 12 is we introduce you to both tests of association and predictive modeling. Now, we're going to learn 3 tests of association over the next few weeks. Notice here that the type of test of association that we do is based on how the data are scaled. If our data are nominal, we're going to do the chi-square test of independence. If our data are ordinal, we're going to do what's called the Spearman's rank order correlation coefficient. I actually think this may not be in Orris's book, but we'll nevertheless do it. And then the topic of chapter 12 is the Pearson correlation coefficient. And if we want to do a test of association when our data are interval or ratio in scale, we do the Pearson correlation coefficient. Okay? So this is a big deal. In all facets of business, oftentimes we do tests of association. And again, let me reiterate that the appropriate test of association is based on how the data are scaled. Nominal, we do the chi-square test. Ordinal, we're going to do the Spearman's rank order correlation coefficient, or the topic of chapter 12, if our data are scaled interval or ratio, then we'll do the Pearson correlation coefficient. Hopefully now this begins to reinforce why I think it's so important for you to understand that little table from earlier in the semester that shows descriptive statistics organized by how data are scaled. Now, when it comes to predictive modeling, that's the third category of inferential statistics that we'll learn in MS-264. When it comes to predictive modeling, in chapter 12, we deal with this, where we have one independent variable. And when we do predictive modeling with one independent variable, that's called simple regression. As Orris shows in the book, chapter 12, and as I showed you in some of the earlier mini lectures, the simple regression model is organized around the notion of y equals a plus b times x, where y is our dependent variable. That's the variable that we're trying to predict. X is our independent variable. That's the value that we're using to predict our dependent variable. And B is the measure of how responsive is variable Y to changes in X. Okay? Now, I'll defer this discussion on multiple regression until another time. This is actually, I think, chapter 13 in Orris's book. But when we do predictive modeling, we set up the hierarchy based on how many independent variables we have. As I said a moment ago, if you have one independent variable, you do simple regression. If you have two or more independent variables, you do multiple regression. I think this is a really good model for you to try to study and understand so that you can have some sense of where we've been so far through tests of differences. Where we are right now, we're working on both tests of association and predictive modeling. And when I say where we are right now in terms of chapter 12, we're working on, let's say, the Pearson correlation coefficient and simple regression. Over the next couple of weeks, you'll also learn how to do the Spearman's rank order correlation coefficient. You'll learn how to do the chi-square test of independence. And I'll at least introduce you to the notion of multiple regression. We'll probably not spend much time on multiple regression, although we will do some. Thank you.